Hello, everybody. I hope you're all doing well. Um, uh, yeah, we've only got, I think, a couple more, 2 or 3 weeks left to go. And yes, today I'm going to, talk more about global change, and then the next time, or trends in global change. And, to understand what to do, we need to know the science behind the global change itself. Of course, I'm not a climate scientist, and but there is vast literature out there on this, and I'm just going to be going through an overview really based on the International Panel on Climate Change reporting out their findings in the 2023, and just using some of their materials just to show you what the scientific consensus is on global change. So yeah. And then next time, I'm going to also rely on what the IPCC, International Panel on Climate Change, is saying about what we can do to mitigate and solve climate change. And I say solve climate change not as a, oh, Pollyanna thing, thinking, oh, well, we can never solve this. I really, we do have a rough road to hoe ahead of us, but I really believe that if we, use our knowledge and use our science and evidence-based knowledge and all of the principles of how to tend and care for Mother Earth, that we can solve this problem. I really and know, because I've worked in forests for my entire life, and I know that forests are, you know, they rebound, they recover, but they also need our help. Okay, so with that preamble, I'll just go on and oh, and I don't have my mouse. I got to get my mouse ready. Jeff, it's here. Okay, here we go. Okay. So this lecture, I've got some learning objectives, understanding trends in global change. Then I'm going to talk about some of the myths around climate change. So getting into, why we have inaction, but then what do we have to do to get to action? There's a lot of myths out there about climate change, and they've been around for a long time. Knowing that scientists have known that climate is changing since the early 1800s. And why is it that we have not acted on this? What is it about our human psyche that has prevented us from acting, and how do we overcome that? So I'm going to talk about that. 4 behaviors of climate denialism, which has gotten us to where we are today. How do we dispel that? And then what actions can we take? And then then I'll lead the next time into what these actions are. So I'm going to start with this, which was going to be the ending of the last lecture, where I was talking about forest practices, and talking about, I was talking about the Hippocratic Oath, to do no harm, the precautionary principle that even without complete scientific evidence, it doesn't mean you don't act. And then how we have in forestry kind of ignored these basic tenets, and in the name of economic gain. And not that economics is bad, it's not. Of course, we need economics. This is how we organize ourselves. Maybe those economic models need to be tweaked or transformed. But that we kind of let certain actors in that economic game benefit more than the public, the people. Anyway, so I wanted to, and then I showed you, what are the harvesting techniques that we've used, and that, of all these incredible, well thought out, very experimented with, successful regeneration methods for harvesting trees while still leaving a forest behind that will regenerate and be healthy. There are many, many options in our toolkit that will allow us to adapt and apply these regeneration methods across different ecosystems to get great results. But what we've defaulted to in British Columbia and Canada as a whole, and now more and more around the world, is what we call clear cutting. And clear cutting actually has devastating effects on ecosystems. Whether you look at biodiversity, carbon pools, hydrology, regeneration, when you don't leave trees behind or legacies behind, ecosystem legacies, it's a lot harder for these ecosystems to recover. So And then I wanted to end that last lecture with this honorable harvest. And so I'm just going to tell it to you now. There is an Indigenous writer, you've probably heard of her, Robin Wall Kimmerer. She's Potawatomi. She's from the eastern U.S., from New York State. And she wrote a book called Braiding Sweetgrass. And I really encourage you to go pick up that book and read it. It's really a really transformative read. But she writes, the indigenous, and so this is what I think, I really believe that these are principles that we can live by to get to solving climate change. What she writes is that in the indigenous canon of principles and practices that govern the exchange of life for life. This is the honorable harvest, emphasizing reciprocity, the give and take, gratitude. If you are taking from an ecosystem, to be in gratitude to Mother Earth for providing for us and for all our relations, and making sure that these are sustainable harvests, and that we're acting sustainably with the natural world. And she goes into more detail in her book about what these principles are. What are the indigenous principles and practices? And to know that we all come from Mother Earth, right? We all come from the same germ cells from billions of years ago or millions of years ago. And that we have these things in common. It's not hard for us to understand these things, but just to reiterate, because we lose our way. But these principles are to ask for permission from Mother Earth if it's okay to come in here and take or to use for ourselves the great gifts of creation of the Creator. Or whoever you believe in, that Mother Earth has provided, to take only what we need and no more. And I think that when we remove ourselves from the land, which is what has happened really in our global economy, that the people who are making decisions are not on the land. And so they don't really know what is taking too much. And so that's where people being in the land is really, really important, because we know if our valley has been clear cut from top to bottom, that that more has been taken than what is needed by those people, or who's in charge. So the principle then, only take what you need. The other one, never take the first or the last. And what this means is to be responsible and judicious in what we are using for ourselves. And if you don't take the first, you just say, okay, I'm going to leave the first for the next generations. In indigenous knowledge systems, they talk about 7 generations. It's 7 generations in the past and 7 generations into the future. So making sure that we leave enough for the next generations by by being very careful. And this kind of rule, don't take the first that you see, it's kind of greedy. Like, think about it, and don't take the last. Leave something for the next generations. To harvest respectfully. So if cutting down all the forest in a clear cut is what you're doing, it's not very respectful for those next generations of trees and plants that need to live there, or the bears that require old trees to den in, and so on. And to give back, showing gratitude. And showing gratitude means tending the land. So if we take a cedar tree for its bark or its canoes, or for our house, or whatever it might be, to have gratitude to this. When we lose the gratitude, we lose so much, right? We lose our way. And so that is a canon that I think that at the larger scale, who are, pulling the strings of how much to harvest, or that piece is lost. And that's why, when we're on the land, people are on the land, in the forest, tending the forest, that's when we can practice these basic canons. And then when we do this, showing gratitude, tending the land, and sustaining the source of this life, then we've found our way again. Okay, so I encourage you to read Braiding Sweetgrass and other books that Robin has published. And so I may have shown you this picture before, but these principles are really what underlies people questioning what's happening in forests. This is Fairy Creek. Fairy Creek is just north of Victoria. It was the site in 2021 of a massive protest against the clear-cut logging of this watershed. It's the last untouched watershed in the working forest on Vancouver Island, and they were going to clear cut it, and so people rose up and said no. We know what the climate change predictions are showing. We know that clear cutting, in particular, but forest harvesting is one of the main contributors to loss of biodiversity worldwide. It releases massive amounts of carbon when we do this. And in fact, this watershed absorbs almost all of the emissions from cars that are in Victoria. So it's a major carbon sink for Vancouver Island. And so that protest happened, and to protect the trees and protect the species that live in the forest. And it turned out through citizen science, people getting it out there and protesting, they also documented the species that exist in these forests, as part of their act of civil disobedience as citizen scientists. And they documented that there's over 300 species of plants and fungi and lichens in this forest, of which almost 20 of them are on the red or yellow or blue listed for endangered species in Canada. It's interesting because our Species at Risk Act is actually a federal act. It's not a provincial act. And the provincial government has very, very weak legislation over species at risk. And so even though this documentation of all these species at risk, even red listed species, it was ignored, right, provincially, because the province governs forestry. And so they ignored federal law. But now, as a result of the protests at Fairy Creek, that Species at Risk Act in British Columbia is now being worked on, and I think has actually been passed in legislation. So there'll be more teeth here. But I'm telling you this all because it really matters to stand up for these forests. The ones that, it's important that we protect the ones that we have left. They're huge biodiversity pools, hotspots, and carbon sinks. I want to, before I start getting into the climate science that I'm going to sort of go over for you, there is a famous climate scientist that you may have heard of. His name is Michael Mann. This is him. He just published this book last year called Our Fragile Moment. And he's talking about this moment in time, how this is, we've had this moment for quite a long time. It's a pregnant pause, if you will. But we really are at this crucial crossroads over what we do with climate change. Michael Mann was vilified in the media for his work. He's a scientist, I think is at the University of Pennsylvania. I'm not sure if that's exactly right, but in the East Coast, very reputable university, published hundreds of papers, and still, as a climate scientist, he was vilified by the media, by the I will say right wing, far right fringe groups, and it was very hard on him. And he was accused of, this is the lengths they will go to, that he was accused of being a pedophile, right? And of course it was completely false, but it was all about undermining climate science. And he actually sued the people who who made those public social media accusations, and he won last year. And so I'm telling you these stories because they're positive stories. When people stand up and fight for their rights, it matters. So I invite you to look at this YouTube video, and he talks about this. Okay, so let's talk about, this is a good segue into what the arguments is around climate change. There are different forces on Earth that result in climate change. There are natural causes, and then there's anthropogenic causes. And generally, the climate denialism, which I'm going to go into more, is around this thinking that climate change is a natural thing. It's just, it's just another fluctuation in the natural patterns of climate and climate has been changing on Earth for, forever, for various reasons. But this is, the main argument over denialism is really that climate change, well, it's here. At first it was, oh, it doesn't exist, but now you can't deny it. So then the argument is, well, did people cause it or not? So let's look at those different forcings on climate change. There are different natural non-greenhouse gas forces that cause climate forcing or climate change. So greenhouse gas emissions, this is what we're concerned about in this course, but that's one. There's also variations in the wobbles of the Earth, orbital variations. There's variations in solar output from the sun, flares and so on that can cause changes in our climate. Volcanoes, when they erupt, they spread lots of ash and they can create, diminished sun reaching the Earth, and that has caused climate change in the past. Plate tectonics, the shifting earthquakes and so on can also cause major changes in our climate. These are usually, not short, they're short-lived in the time span of Earth, but they can have dramatic impacts. They think that that the disappearance of the dinosaurs during the Mesozoic period was due to a meteor hitting the Earth. I mean, so these are external things that don't have anything to do with humans, but there is ample evidence that this greenhouse gas increase caused by humans is a real thing. And so what are those causes for increasing greenhouse gases? Well, it's the burning of fossil fuels. So that's the number one. That's the number one source. I think that, burning of coal, oil and gas, development of these ancient carbon sources probably accounts for 3/4 of greenhouse gases in the atmosphere. The others, deforestation, or we can call generally land use change. So that is like, the forests, which cover 31% of the Earth's surface. And we've been, cutting down forests for a long time, and that's sped up and sped up and sped up. So deforestation coupled with agricultural development and urban development, industrial development, probably accounts for the other 25% of greenhouse gas emissions. So these other things, coal mining, I lump into industrial processes and air pollution, or sorry, and in these industrial processes, another one is the production of cement. Production of cement emits a lot of CO2 as well. So yeah, I'm kind of confusing these numbers, but just here's the numbers I want you to know. About 3/4 of the greenhouse gas emissions are from deforestation, land use change, coal mining, and production of cement, and other air pollution. And about 1/4 comes from land use change, which includes deforestation. Okay. How does this work? And you can go into the IPCC reports and get a lot more detail about this, but basically we have greenhouse gases in our atmosphere naturally, carbon dioxide, methane, nitrous oxides, and these are like a blanket around our atmosphere. And without greenhouse gas increases, it works basically the same way. It's just that the sun, emits solar radiation, hits the Earth, and then the Earth re-radiates heat back into the atmosphere. And that heat, a large part of it escapes into the atmosphere, but some of it is kept by this blanket of greenhouse gases around the Earth. And so they're reflected back to the Earth's atmosphere, and it warms it and makes it habitable for us and all our relations. When we have increased greenhouse gases from fossil fuels, cement production, and land use change, we have more of these greenhouse gases in the atmosphere, right? More CO2, more methane, more nitrous oxides. And so there, in that way, there is more heat. There's just as much coming down from the sun. That doesn't change. But what is re-radiated back changes a little bit because we've changed basically the reflectance of the Earth through changing land. And then more of it is then reflected back from this blanket of gases around the Earth. So this arrow is much bigger than when prior to 200 years ago when we started burning coal and fossil fuels. So that's how it works. You just have less heat escaping back into the atmosphere and more held in our atmosphere, and that's what's causing the warming. So currently, the CO2 concentration is about 40% higher than from pre-industrial times. So that would be like, really industrialism started in the late 1800s. There was, scientists knew about this greenhouse gas effect in the early 1800s, but they didn't, it was really didn't get a lot of traction. It stayed within the scientific world, even though, even the industrial moguls did understand and did know about it. But it wasn't until the Industrial Revolution and then, more burning of coal and population increase that we started to really increase greenhouse gases. And now we're at 40% higher than these pre-industrial levels. There's not just carbon dioxide, that's the biggest greenhouse gas, and it's the one of the greatest concern, and that's our polling question. There's other ones. So there's methane, CH4. It's a far stronger greenhouse gas than CO2. It actually has 25 times the greenhouse gas effect that CO2 does. Nitrous oxide, also a much, much stronger greenhouse gas, even more than methane, but they're just in like much smaller concentrations. Okay, so here is our polling question. Which greenhouse gas is of greatest concern?
Stars. Yeah, it's perfect.
Great, good. Yeah, it's interesting. You notice I've got water in there as it is also a greenhouse gas. It's in our atmosphere as well. And clouds, they do trap heat. But that cloud cover, of course, it changes spatially, but it is not the cause of the big greenhouse effect overall. So how do we know these greenhouse gases are increasing? And I think I might have mentioned this before, but the earliest scientists, the chemists and physicists I mentioned, they were writing about this in the early 1800s. It was brought up in the great science conferences in Europe at the time. And largely ignored or argued against, but the knowledge was there, and there was a prediction even back then that if we increase greenhouse gases in our atmosphere by burning fossil fuels, even in the early 1800s, that we would see heating of the atmosphere. It wasn't until the 1950s until people really started to take it more seriously, and there was one of the NOAA stations, National Atmospheric and Ocean and Atmospheric stations in the United States, was set up on Hawaii on a volcano called Mauna Loa. And this observatory had a scientist in it named Keeling. And Keeling took it upon himself, he was a chemist, to start measuring these gases in the atmosphere at Mauna Loa Observatory. It wasn't a government initiated project, it was his own project. And then he started observing these trends, right, in CO2 increases over time. And then he was able to, report it out, and then the government started basically funding the annual capture, or actually the capturing these gases probably now every second. And not only was CO2 on this increasing trajectory, but there was also seasonal variations. It goes up and down every year. And he was able to figure out that the reason it goes up and down each year is that during the spring in the equatorial regions, where most of the forest biomass is, or the biggest forest, the biggest sinks for CO2, are in the tropical regions, and this is when they were they were leafing out, and then they were absorbing the CO2, which caused the CO2 concentrations in the atmosphere to decline. And then in the fall, when they shed their leaves for the winter, and then there was less absorption, less photosynthesis, and then the concentrations went up, and so up and down, up and down, up and down. So he was able to measure this seasonal variation. But mostly he was able to just say, hey, there's this increase going on and it's not stopping. And it's interesting because I just read actually in the news last week that the current Trump administration is shutting down Mauna Loa, which is very short-sighted, but it just kind of also fits with their mandate. So here's the question. It's supposed to be polling question 2, but Sorry, I've got the same polling question. Forget it. We've already done that. It's CO2. Okay. Oh, here's number two. Sorry, I made that mistake. Here's question number two. So how do we've got this record of actually taking gas samples from the atmosphere from the 1950s, but we actually have a much longer record. And if you go back, actually a record that goes back 800,000 years for CO2 concentration. And the way this was reconstructed was actually through ice cores. So there's certain ice sheets, especially in the Antarctica, that are used for this work, and they drill down, and each year there's a layer of ice that is put down, and there's bubbles in that ice, and in those bubbles there are the gases in the atmosphere, and so they've been able to shave off each year down to 800,000 years and analyze the concentration of the different greenhouse gases in each layer of ice. And that's how they've reconstructed this big, long record. There's other records that have been used in the last, few thousand years as well, and that's through tree rings. So you can, core. There's the oldest trees on Earth are over 1,000 years in Finland, and you can core those growth rings and reconstruct what the carbon dioxide concentrations were then. Is very using isotopes. I don't understand the method myself completely, but that is another method. But the main one, the one that's given us this big long record, are ice cores. And you can see CO2 has been fluctuating over time through these, natural variations, flares of the sun, the wobbles of the earth, and so on. But it's in the last, the last 100 years that we've seen this dramatic increase to the current levels. So here's our and before I go back, Michael Mann, remember I just mentioned Michael Mann, he was the first one to publish this figure, and he called it the hockey stick figure, that this is like the shaft of the hockey stick, and there's the, the thing that you hit with the puck, you hit the puck with. Anyway, so he called it the hockey stick curve, and that is, raised the ire of his critics. But anyway, here's our question. What is the source of the longest CO2 record?
Stores. That's cool. I'm surprised about the distribution. So, I mean, there's 60% choose B, but there still have 20% students choose A and 12% students choose C.
Okay. So the longest CO2 record, yeah, it's definitely the ice cores.
Yeah.
We only have 50 year or 75 years from Mauna Loa, and tree rings only as old as the oldest trees, which are just over 1,000. So it's definitely the ice cores. Okay. All right. So getting back to Fairy Creek then. When the environmental and indigenous protesters, tree defenders, forest defenders launched their opposition, it's because they knew, right? They knew about the impacts of this kind of activity that would be happening in Fairy Creek, which is this untouched watershed just over the crown here, this is what it would look like. And we would be emitting massive amounts of CO2, and we'd lose the biodiversity that is dependent on old growth forests. And so, at the end of the day, our current government has announced, after all those protests where thousands of people were out there, many people were arrested, that the government today, when they were just elected, announced that they're going to protect Fairy Creek for the foreseeable future. It's going to be in the law. So again, these protests matter. It's important that we do this because this is where we can, these kinds of movements are the solutions to the climate problem. And I'm just to put a finer point on it, when we disrupt the land base like that, we create other additional effects, and the problem, can accelerate, and that's what we're seeing: accelerate and augment. There's cumulative effects, and I might have shown you this already, but just when we burn fossil fuels and we do land use change, we fuel climate change. And this causes snowpack declines, which creates hotter air in the atmosphere, which increases lightning. There's more energy up there, so there's more lightning, which makes these drier forests, because it's hotter and drier, more conducive to burning down. And these fires are becoming, the fire regimes are changing. They're more severe, they're more intense, and they're more extensive. And they're also erodible. And these cumulative effects cause even more CO2 increases. So we have to understand these feedbacks so we can disrupt the feedback loop so that we can turn it around so that it goes the other way. So we're restoring the land, drawing down CO2, and creating a healthier planet. Okay, so let's get back to how we're responding to this. We know, you could argue, about some of the causes, I guess, about climate change, but the scientific evidence, 99% of scientists agree that human beings and what we do is causing climate change. But there's the denialism, and there's different forms of it, or our inability to act. We convince ourselves, we have arguments in our brains, as individuals, and as collectives, that's delayed our action. So I want to dispel these things so that we can understand what's going on here. The first thing that we tell ourselves as individuals, or probably not you, but or me or Jeff, but collectively countries around the world, we say, well, it's not that bad. However, I can quickly dispel that, that was something that was said when I was a graduate student. Now I think that, that the clarion call is there. And I'm just putting up this Associated Press release that was from 2023, so the year before last. And it was, that scientists had measured that the greenhouse gases had increased, or that the global temperature increase had exceeded 1.5 degrees, which scientists say is the red line that we can't cross. And they're saying we're on red alert. And so this is from the World Meteorological Organization speaking out, and saying the United Nations is issuing a red alert about global warming, and that the temperatures are smashing records, greenhouse gases are increasing, land and water temperatures are increasing, so on. You've heard it all. And they said there's a high probability that 2024, which just happened last year, will be another record-setting year, and it was. And so this kind of speaking out by the highest governing bodies of the world is really, really important. It gets the attention of nations. Okay. Before I go on to this, I will say, it can be very depressing, but here's one thing that Michael Mann has said, and when you look at his YouTube video, he explains this, is that when you look at the overall trends, so there's these short-term variations in temperature and CO2 and other greenhouse gases, but there's longer-term trends as well. And when he analyzes the long-term trends as a climate scientist, he says that what he can see is that because of our efforts to go to renewable energy and to get off fossil fuels, even though it's slow and bumpy, that we've seen this sort of maxing out of CO2 increase. We've kind of hit a peaking point. That's what his prediction, that's what his models show. And so that's very encouraging. We've got to keep doing that so that we can make sure that peaking thing doesn't get away on us, and that we truly are starting to level off. Okay, so this is from the IPCC. It's global surface temperature in relation to different scenarios for emissions. So the zero, it's relative to the 1850 to 1900 period, I believe. And it's saying, okay, relative to that period, prior to that, before 2011, that the greenhouse gases were below this 1 degree increase, or it was around zero, and it was fluctuating, but it was pretty stable. And then around 2015, we started to exceed 1.1 degree relative to 1850 to 1900 normals. And then these are different scenarios, is that if we reduce emissions, what we can expect for global change or temperature increases. You can see there's these shaded areas are the uncertainty around these predictions. There's a lot of things that aren't known. We can't predict the future. There's a huge amount of uncertainty, but there is pretty good evidence that if we can reduce our emissions to low or very low, that we can keep under this uh, this 1.5 degree, which is considered the red line that we don't want to cross. But if we keep emitting high emissions, then we're going to see increases of up to 4 to 5 degrees by 2100. We won't, we don't want to go there. We want to be down here in the low to very low so that the future looks, is good and habitable. Okay, so now in 2024, did I put this up here? Okay. The global temperature increase in 2024 was 1.55 degrees Celsius. Okay, so here's it. It's already getting to that threshold. So here's our polling question.
Start. Yeah, I mean, maybe still didn't miss the point. It's evenly, yeah.
Okay, so let me explain that question again then. So relative to the period, I'm going to go back to that slide, 1850 to 1900. The question is, what has been the increase in global temperature, so global surface temperature relative to that normal level? And when we look at 2024 last year, what the global surface temperature was, it was a 1.55 degree increase relative to this period of 1850 to 1900. Okay, so that's the question. The answer is E. It's 1.55. Okay, so what are some of the consequences of this that the IPCC is predicting? So IPCC is really good at communicating what the massive amount of science that they're putting together in these very visual figures. So I'm going to use this straight from their report, the 2023 report. So with every increment in global warming, these are some of the consequences. So 1.5 degrees Celsius, the report came out in 2023, and that was the year that it was 1.5 degrees Celsius increase. 2024 is 1.55. And then there's like what would happen at 2 degree increase, 3 degree increase, 4 degree increase by 2100. And so it's saying, okay, look at these factors, hottest day temperature change, and it's saying, okay, globally, what will those temperature changes be, and how will they vary around the world? So at a 1.5 degree average increase over the global surface, we can see, some areas are going to be hotter than others. These more equatorial regions are going to experience hotter conditions than the more on average than northerly or more mid-latitude regions. As we get more and more temperature increases, these hotter the variation in spatial heat, those spatial variations stay, but it's more and more accentuated. You'll see, I said at higher latitudes, I'm talking about like the boreal forest, it's still relatively cool, but as we get into these higher increases by 2100, you can see the boreal and the Antarctica, there is kind of this thing called polar amplification of increased temperatures. And this is because in the polar regions, as it gets hotter, we have more melting of snow and more permafrost melting. And that melting of snow is really important in ice caps because the ice and the snow reflect heat back to the atmosphere. When it melts, the Earth absorbs that heat and it warms up more. So the polar amplification means that as you get to more northerly, snowier latitudes, the effects are bigger because of snowmelt, or what they call albedo changes, the reflection changes. So temperature is a very clear picture, and there's spatial variation around the world. Moisture, soil moisture will also change. And so it's saying that, where it's brown, that's where we're going to see declines. So, in the Great Plains regions of the US, up into the prairies of Canada, in the Amazon, and down into Patagonia, we're going to see a decline in soil moisture. But other parts of the world, in Asia and parts of Africa, we're going to see increases. So the precipitation it varies, it shifts the precipitation regimes. And these will accentuate over time. So the darker the brown, the more drought will be experienced in these areas. So it's definitely not the same all over the world. And it's interesting that the hot areas, these areas that are also hotter are also going to have drier soils. That makes sense. And then here's the wettest day precipitation range. We're going to have, where it's blue, we're going to see more increases in rainfall, and where it's brown, lower rainfall, changes in distribution of rainfall. Okay, I'm going to move on from that. Okay, so what do these changes in climate and precipitation and temperature mean for humans and for other species? And so the IPCC has also made predictions about this under these different temperature increase scenarios. So with a 1.5-degree increase, which we're already at, there's going to be losses in species. And so you can see all this brown, especially around in the tropical forests. And then as these predictions get worse, or increasing temperatures, these losses are much, much greater. Look at this, 100% is purple, 100% loss of species in these regions at a 4-degree temperature increase. I mean, this is shocking. This means we cannot go there, right? We just cannot go there. Risks to human health follows the same kind of trend, where you have risks of human health for year round in these, these equatorial countries. We definitely do not want to be in that. We want to be staying down here at this 1.5 degrees. So that means we need to act, right? So I keep saying tropical. That's the tropical biomes that are going to be at the greatest risk. So here's our polling question.
Start. Yeah. Yeah, it's perfect.
Great. Okay. I'm going to keep going. We'll take a break at 11:55, and we'll take a 5-minute break then. Okay, so that was the first myth, our thinking that it's not that bad. Well, I hope I've dispelled that. I think the IPCC has actually dispelled that myth very, very well with their report. Okay, the second myth is that, okay, so we have this, but we don't have to act now. We can afford to delay action, and then we'll deal with this down the road. And this has really been a lot of the thinking. It's amazing. Like it's procrastination, if you will, or not acting, but this has been a major driver of why we haven't, what we haven't done. We haven't acted very well as a globe. Okay, so why is it a myth that we can wait? Well, you can think of the atmosphere like a bathtub that can be filled up with greenhouse gases. And you can only fill that bathtub so much to where you get to the point where it's full and it overflows. And so scientists have estimated that if we want to stay below, and they're using the 2-degree threshold here, which is where we're kind of heading right now, that if we want to reduce it to a 2-degree threshold, we can't exceed, our bathtub fills up at 450 parts per million of CO2 by 2050. So we don't want to have our bathtub overflowing. So 450 is really like the drop dead point, I think, before we're in these very critical, where we have a lot of biodiversity losses, major human life losses, and so on. Where does that CO2 go? So the excess CO2, half of it goes into sinks, roughly, oceans and soils and areas that are restored, forests are coming back. And the other 50% of these excess gases stays up in the atmosphere, and they create the greenhouse effect. And this was said many, many years ago by uh, the United Nations that with every year we use up our quota, we're using up our quota, and we're losing out the flexibility to act and to avoid dangerous consequences. So let me show you a little bit more why he says every year we delay, the harder it gets. So this is actually from a book I read. But it was in the 2010 roughly, and I read this book called Requiem for a Species, and it explains this very, very well. And it says, okay, CO2 increases, emissions or CO2 emissions have been going up and up and up, and they're expressing this in gigatons of CO2 equivalents in the atmosphere. And it's saying, okay, we're going along here. This is time. We're emitting, emitting, emitting. And then at 2010, so this is when I read the book, they said, if we act now, we can reduce our emissions by 2%. And this will half, by 1990, we'll have halved all of our emissions relative to 1990, and that we'll stay below this 2-degree increase. So that meant so the important thing here is we only really needed to reduce our emissions by 2% if we had acted in 2010. Well, we didn't act in 2010. So 2015 came along. He says, well, if you wait a bit longer, 5 more years, you have to reduce emissions by 3.6% in order to stay below the 2-degree threshold. Every year we delay acting, we have to reduce our emissions more and more and more in order to stay below this 2-degree increase. And in fact, if we wait until 2025, which is where we're at right now, we have to have a 12% decline in CO2 emissions. And we're not even going to be able to half our emissions by then, even by these actions. And we're actually going to have to increase the sinks in the earth in order to absorb that excess CO2 to stay below 2 degrees. So it's not just a matter of reducing emissions. We have to increase the sinks as well. We've got to reduce the sources and increase the sinks. So we're at that point right now. We've got to reduce by 12%, and we've got to reduce emissions, and we've got to increase sinks. So every year that we wait, it gets harder and harder and harder to do that. And so that's why they say, 2030, we have to be acting by 2030. And luckily, no, not luckily, through the hard work of many people, and as Michael Mann reports, we are starting to level off our emissions. We are getting to this leveling off point that's up here at 2030. So we got to keep going, right? We've got to be ingenious, we've got to be innovative, and we've got to support the initiatives to reduce greenhouse gas emissions. Okay, how are we doing for time? I'll just go through one more slide here. So what are the chances that we can do this with our policies? So if we look at all of the policies globally now, and this is CO2 emissions over time, again, if we implement all the policies that are in place right now, we will, level off, but we still are going to have warming of up to 3.2 degrees by 2100. Okay, so and there's a lot of variation around that. There's a lot of uncertainty, but doing what we say we're going to do now will limit it below 3.2. Remember, that's still disastrous for us globally. So if we want to limit to under 2 degrees, we've got to implement much more drastic approaches, increasing sink strength, reforesting, not clear cutting our forests, reducing deforestation and so on, returning, land to productive states. Okay, so now this year 2030, let's look at that. That's right around here, or 2050. No, so that actually forget 2030. In 2050, scientists are saying if we can do these really dramatic limits of CO2 emissions by 2050, we will be able to limit warming below 1.5 degrees. Okay, so We can recover some of the, we're at 1.55 right now. We can recover that. But we've got to really move on this. So 2050 is kind of what they're saying. Okay, we got to have this stuff implemented. 2030 would be better, but 2050 is the absolute drop dead. I hate to use that term. We've got to be acting by then. So here's our polling question. What year do we need to reach net zero emissions by in order to avoid exceeding the 1.5?
Start, yeah. That's perfect.
Okay, good.
Yeah.
Excellent. All right, let's take a break and we'll be back at noon. Okay, let's continue on. Um, so I hope that I was able to, with these last few slides, point out that it's really important that we act now, that we can't delay any longer. A third myth is that, 2 degrees is okay. That the shifting baseline, it used to be, 1.5 was what we don't wanted to stay below. And then people said, oh, well, we blew past us, 2 degrees is okay. It's actually not okay. We can't, it jeopardizes too much to let it go further. So, and this is the IPCC again, which is a United Nations governing body that puts out these reports that shows what the risks of exceeding 1.5 or 2 degrees or even up to 5 degrees. And they have these beautiful integrated charts that help us understand this. So this is a figure I showed you before of, the emission scenarios and what temperature increases we can expect under these emission scenarios. And then it talks about the risks of raising temperatures above these. So, there's 2 bars in each one of the risk factors that it looks at. One of them is on the left is the bar of what the IPCC was reporting in 2014. And then they adjusted their risk assessments because they underestimated the risks in 2022. So it's just comparing these two bars for all of these different risk factors. So how you read this, it says, okay, what are the risks to unique and threatened ecosystems? In 2014, this left bar, it said that, well, if there's a 1 degree increase, there is actually a moderate to high risk, that's over here, the color of the bars, that these rare and unique ecosystems will be threatened, like coral reefs and kelp forests and so on. And then they revised their estimates in 2022 and say, actually, we underestimated the risk to these. So that would have been based on like many scientists making observations of what is actually happening on the ground. And then they're saying if we get to 2 degrees, we're at high or very high. In their 22 estimate, we're already at very high risk. That it's the highest risk possible. So the myth that we can go to 2 degrees, not very good news for these unique and threatened ecosystems. Extreme weather events, again, back right up to very high, and we're experiencing that now, even at 1.5 degrees. Distribution of impacts. It'll be more global. The more, the darker the part of the bar, the more global those distributions will be. Aggregate impacts, and it just goes through these different impacts, large-scale singular events that would be like a massive wildfire, like the Fort McMurray fire. Much more risk of that. It says moderate to high risk of these big global events at a 2 degree increase. It says down here, let's look down here, these risks aren't the same across the world. And what the damaging agents are the risks aren't the same either. So let's look here. Wildfire damage, these are in land-based ecosystems. Wildfire damage with a 1.5 degree or 2 degree increase. High risk that we're going to see many, people being exposed to increased fire seasons, more severe fire, more extensive fire. Permafrost degradation, already in the very high impact at 2 degree increase. And you can go across here. Look at this yourself. Biodiversity loss at 2 degrees, we're already at very high. In the ocean ecosystems, the impacts are really strongly affect, most affected ecosystems are these warm water coral ecosystems. And you'll hear that in the news, like, the collapsing of the coral reefs. That is happening already. And at 2 degrees, most of them will be collapsing. So yeah, so I think that this is it's like, it's a reality check. Like we don't want to go there. We want to mitigate and reverse some of these effects. Okay, so the polling question is, what system is at the greatest risk from warming? And it is in these warm water coral reefs.
Start. Yeah, it's perfect.
Great. Good work, everybody. Okay, so let's get on to the fourth myth. I hope I've dispelled the myth that 2 degrees is just, we don't want to go there. The impacts are too great. The fourth myth is that climate change will be predictable and linear and we can adapt to it. So let's just look at this again. This is kind of a difficult graph to look at, but this is, it says the adverse impacts, sorry, I've got to move this, from human caused climate change will continue to intensify. Okay, so it's going over time with the global temperature increases above the 1850 to 1900 levels, the standard, that we're going to look at things against. What are the impacts of warming under the different emission scenarios? So this is, and what it's trying to say is that the impacts, as it gets more and more red, the temperature increases will be higher and higher. So those are very high risk ecosystems, or very, very high risk impacts. And it's trying to relate it to us as people, right? It's trying to relate what's going to impact me. And really we are such individual, creatures of individuality. What's going to affect me and my family? So if you were born in 2020, and I think most of you were born probably not in 2020, you'd be 5 years old, but you were born in the mid 1990s, I guess. Or no, the mid 20s. I don't know. Anyway, you're all about 20 years old. So 2005. So that's between these two things. And it's saying, what are the risks to you as you get older? If you're at 70, by the time you're 70 years old, so if you were born in 2005 and when in 2075, when you're 70 years old, what will be the risks of you if we're at 4 degrees? And it's just saying that the risks are very, very high that it's going to affect your health and your longevity. I was born in 1960, a long time ago. And so a little after this, but my risks when I'm 70 are going to be much lower than your risks to your health than when you're 70. You don't want that, right? You want to have a healthy, happy, comfort, life where you're productive and healthy. And so it really brings home to us as individuals of that we want to act for ourselves, our family, and for the whole world. And so these risks then are these changes. We kind of fool ourselves that they're predictable, but they're actually not that predictable. I mean, there's predictions, but there's all kinds of surprises, and that's how ecosystems or complex systems work. Is you get non-linear changes, and I've showed you this graph before, but it's not going to be a linear change, right? A slow, gradual change till you're 70. It's going to be like sudden changes, like the calving of ice fields and the melting of glaciers. Suddenly, you'll see these big, uh, very pointed events that make big changes. Some of these, are reversible. So here's a threshold change where you get a sudden change because the polar ice cap melted. But if you restore the ice cap, you can go back to those original conditions. So there's these other, catastrophic changes where you get a hysteresis or a bifurcation where it rips apart and it can't recover to what it was before. We don't want to get into this C nonlinear catastrophic bifurcations. We want to, we're going to probably be dealing with B, but we want to be able to do that so that we can recover these systems as we solve climate change. I've shown you this cup and ball model and I'm just going to bring it back to that, this cup and ball model of ecosystem stability. And remember, I was talking about how the width of the cup, I called it ecosystem resilience. They're calling the depth of it resilience here. So just try to not get confused by that. It's just this is the state or the domain of the ecosystem, and it's called a stability domain or stability regime, regime one. And this figure is saying, okay, the state of our ecosystem, the desired for in our case, the forest, we're talking about forests, in the historic, pre-1900 times, this was the state of the ecosystem. But as we degrade land or change climate, we change the conditions of the cup. We're making it shallower, less resilient and less resistant. And these cumulative effects add up. And so that when you've really compromised or degraded the ecosystem, it's less resilient. So when you get a disturbance like a great big wildfire or an earthquake or a tornado or a hurricane, if the system is already compromised, it's so much easier to flip it into these other regimes, these alternative states. And you can go through various of these changes, and you don't want to get into this collapse system where it's like a forest becomes not a forest. We want to be staying in this cup over here as much as possible and change the depth of the cup through actions, through restoration, through reducing emissions, and so on. Okay, so I've dispelled these myths, I hope. And now if we can say, okay, we have an issue here. We need to act. What is preventing us from acting? And people have dissected this psychology, and I'm just going to give a little brief. We've only got like not that much time left, but there are these different psychodramas that we go through ourselves as individuals, as collectively, as whole political parties, as whole countries. But let's just go through. There's different stages, I would say, of denialism. So the first one is active denial, and this is really based out of fear, where we say, we're not, fear takes us over. We're going to deny it doesn't exist. I've got this little video. I think you can look at it in your own time. We don't have to have time to look at it, but basically it talks about how, the media can also build on and capitalize on our fears of the future. I'm just gonna skip past it, but I invite you to look at that. It talks about how this sort of denialism machine preys on our fear. And then if we can get over the fear, we get into this other thing called causal denial. We'll say, oh, it's not me, or it's not my country, or it's not human-caused climate change. It's something else that we can't really do anything about it. And this really is, we've gotten a hold of our fear, but we're still quite anxious about this. And so we just say, oh, it's happening, but it's something else. And so then um, we adjust our behaviors and say, I'm not going to do anything. I'm too anxious. It's not my problem. This is called causal denial. And this is a really good video picture that shows, we put our head in the sand. And, this causal denial, our anxiety, is very highly exploitable by the climate denial machine. Where does that kind of climate denial machine come from? Well, it's people who have vested interests, or companies or institutions vested interest in the status quo, and they'll create this denial machine. There was an example of that in Alberta, where the Canadian Oil Sands Alliance created a whole bunch of educational materials for climate change in public schools. And it was partly truthful and not fully truthful. It was sort of putting it on to the teachers to say, well, if you go plant trees, we'll solve this problem. And avoiding, getting at the real core source of greenhouse gas emissions and how to create better sinks. It sort of put the blame or the onus on the individual in these materials. This is a type of you know media or vested interests exploiting our anxieties over this and saying, okay, I'll do it, right? So we need to, understand what that is. And then there's this thing we can move from, okay, well, it's, I accept it. I've got over, I'm fearful, I'm anxious. It feels hopeless to me. And so this is what we call maladaptive acceptance. And, you know, these are common things people will tell themselves, me too. I don't care. I'm okay. I'll feel okay. I'll be fine. Or I'll donate to somebody else who's going to, take action. Somebody else can do this. Or blame shifting. We're not going to do anything in Canada if the US won't do anything. Um, or wishful thinking, science will save us. The science is their problem. They'll save us. We have to really, check on ourselves when we do this. It's maladaptive. It means that we don't act. Okay, so then the last stage is sort of like going through the stages of grief, but you actually accept that this is happening and you become adaptive and proactive with this and get involved. And there are certain things that that you can do. You can learn about it, you can reflect on it, you can overcome your fear, reach out and help your fellow people, get involved, be active in helping support institutions that are working on climate change. Be a problem solver yourself. Grassroots movements really, really matter. And I think I've tried to emphasize that with the Fairy Creek movement. It really mattered. And we also have this tool called civil disobedience. And we're seeing this happening all over the world now. The most famous climate change scientist, James Hansen, he he was arrested in protests over climate because he knew, right? And so he made a point of saying, I'm a high profile climate scientist. I'm going to make a point to the world and I'm going to be arrested just to raise the profile of this problem. Here's another example. This was before you guys were probably born, but Wall Street, and I talk about vested interests. This is, people said, okay, that's enough of that. We need to take the power back to the people and have, rights over our own resources, our own land. We're not going to give this over to Wall Street or the stock market or whatever. So people protest. There was a big protest called Occupy Wall Street. And this is just a picture from Fairy Creek. People got together, from young people, old people, Indigenous people, environmental people, people from all walks of life got together to make this, and it made a difference. Okay, so polling question: what behavior is generally dominating global action on climate change? Well, I think that there is no single right answer to this question. I should have put all of them. But I would say you answer what you think where you think we're at. That'll be interesting to see what you say.
All right. Okay, so 13%, so the majority student is 35% choose C and 31% choose B. And we have 15% in A and 15% in D.
Interesting.
Yeah.
We want to have a shift to D. But thank you for being honest about where you think we're at. And we obviously, we all have work to do, and yeah, encourage everybody to move to D, so that we can work on this. Okay, I think that's it. I've got these, this is going to lead to our next lecture on Monday. We need to slow climate change dramatically by reducing emissions. We need to learn, educate, act. There's our economy. We need to rethink our economy, which is, based on growth and consumption, and reduce these things, reduce consumption, inequity, and growth. So that's a lot to leave you with, but I will dig into this next lecture, and have a wonderful weekend, and we'll see you on Monday. Thanks.